Okay, these are the notes that need to be filled in for Thursday and Friday. We started talking about the ADHD experiment in class. If you weren't there, you need to come and get the article and read it. Okay, but we decided, looking at the article, that we could not say that smoking or lead exposure causes ADHD. One, because we didn't do an experiment, and two, because there were many confounding factors. Okay, is there a way to show that smoking causes ADHD? Yes. If we were horrible people, we could do an experiment. So let's say we have 100 preggo women that come from similar environments, socioeconomic statics, genetics, and we told 50 of them to smoke and 50 of them not to smoke. And then we look at the outcome of their pregnancies and of their children. That could be a cause and effect experiment. But sans telling a pregnant woman to smoke, we'd have to do an observation. Okay? So an experiment is an investigation. An experiment investigates how a response variable behaves when the researcher manipulates one or more factors to determine if those factors cause changes in the response variable. The primary difference between an experiment and an observational study, okay, is the way in which the groups are formed. If groups are formed based on the choices of the subjects, then a study is observational. If a researcher assigns groups at random, then it's an experiment. So this is a key difference here. Okay? If human beings are being experimented on, they are called subjects. Other individuals, tomato plants, mice, loads of dirty laundry, anything else, are called experimental units. Okay? An experimental unit is the smallest unit to which a treatment is applied. Again, there is a vocab word for you. Okay? All right, the specific values that the experimenter chooses for a factor are called the levels of the factor, and we're going to talk about that. Well, actually, let's go back up to experimental units. If we had experimental units, what if we had a study on laundry soap? How effective a new soap is. Okay, so if we did an experiment, maybe we use water in one, old soap in another, and new soap in another, but we have to think about what is the experimental unit, okay? Is it the load versus the individual clothes? And the experimental unit would be the smallest thing, it'd be how the individual clothes turn out. And give that just a second, there is a lag. Now let's talk about levels, okay? So let's say we are horrible people, and we're going to ask moms to do an experiment. So, for example, moms smoking and ADHD. Okay, the levels, we could have 3 levels. Not just do you smoke or not, but we could have no smoking. Okay, a half a pack a day, maybe a pack a day, to see not only if smoking affects it, but if it's like maybe we have how much you smoke affects it. Okay, so those are levels. All right, the combination of specific levels from all factors that an experimental unit receives is known as the treatment. So we could go back here and say, what if also the mom got, I don't know, she eats healthy or eats poorly, poor nutrition. Okay. A treatment would be a combination of these. So in this case, we would have 6 treatments, because you could no smoke, and I'm going to do it. Could no smoke and eat healthy, or no smoke and eat poorly. You could a half pack and eat healthy, half pack and eat poorly. Or you could 1 pack and eat healthy, 1 pack and eat poorly. Okay, so those are treatments, and you're going to want to look at examples of that in your book. Okay. A recent study declared that people who go to church have longer life expectancies than people who don't go to church. Do you think this is an observational study or an experiment? Well, I'll tell you right off that this is an observational study because they didn't say, you know what, you 500 people, you find religion, you go to church every Sunday, and you 500 people, you just don't get to, you have to be atheists. And then watch them throughout their life and see who lives longest, okay? This was observational. Assuming there is association between church attendance and longer lives, can we conclude that going to church is the cause? No. Okay. First off, because it was an observation. Secondly, maybe, and this is a big maybe, not being stereotypical, but maybe people who don't go to church do something different than people that do go to church. Like maybe they have some bad habits. And just think about it. How many people you know that go to church regularly smoke? Okay. If you go to church, maybe you don't believe in smoking. But if not, maybe you are a smoker. And there's definitely a big gray range there. Okay. I'm just throwing some stuff out. All right. So there are two types of studies. There's a retrospective study, which selects studies. A retrospective study selects subjects, and then their previous conditions or behaviors are determined. So they look at the history, at the past, okay? Retrospective is the past. For example, in the church study, if researchers use people who have already died and determined whether or not they went to church, that would be retrospective. A prospective study sets it up, okay? They look in the future. They plan. Okay, so they pre-select their subjects and then follow them to observe outcomes. For example, in the church study, if researchers selected churchgoers and non-churchgoers and then waited until they died, that would be a prospective study. Okay. All right, now we're going to talk about designing experiments because you can only do so much with observations. What if we wanted to design an experiment to see if caffeine affects pulse rate? The explanatory variable would be caffeine. Okay, that is what we're changing to see if it explains the change in pulse rate. So the response variable then is pulse rate. Okay, and our experimental units, if we did it on our kids, would be the students in the class. Notice it's the students, not just the class. Okay, before we did an experiment, we would need to have a plan. So here would be our initial plan. We're going to measure initial pulse rate, give each student some caffeine, wait a specific number of time, measure the final pulse rate, and compare the final pulse rate. What are some problems with this plan? Okay, well, if I were to ask you, I bet you guys would come up with prior activity. What if before you came to class, you were at Maverick and you had to run here, sit down, and then I took your initial pulse rate, okay? And then I gave you caffeine. Your heart rate was already fast, so maybe the caffeine is not going to affect it as much. What about maybe while you were at Maverick, you already had some caffeine, so prior caffeine consumption. Along the same lines, maybe you have a caffeine tolerance. Okay, if you are one of those people that gets up and have a big cup of coffee or a Monster Java or a Red Bull or something every day, and then I give you caffeine, your body's pretty used to it and you're not going to freak out. If you give somebody who doesn't have any caffeine a lot of caffeine, their body is going to respond a lot. Okay, some other problems, maybe the person has anxiety about doing this in class, so it makes their heart rate faster. There's just lots of different things. There's no control, okay? We have nothing to compare it to. How fast if you don't have any caffeine, okay? So lots and lots of problems. And here's what we do. Some of these problems, such as telling a joke while waiting for the caffeine, can easily solve by including a control group. So let's say while we're waiting for the caffeine to kick in, I say something really funny or I fall off my desk and you guys start cracking up. That may make your heart rate go up, and that would confound our results, okay? So instead we would have a control group that's also sitting in the room, and so if they see me fall on my face and they laugh, their heart rate went up as well, and it takes out the effect, okay? In our experiments, we can accomplish this by using 2 levels of caffeine. No caffeine and some caffeine, okay? For example, we could assign each member one of the 2 treatments, regular Coke or caffeine-free Coke. Why don't we give Coke to one group and nothing to the other? Okay, that's the whole idea of if you know you have it, okay, it's a mind thing. It's the idea of a placebo, and we'll talk about that, okay? Knowing you have the caffeine might excite you. You got the actual thing. Your heart rate goes up. Knowing you didn't get any of it, okay, you might have a different response. Everything has to be the same. So here's the deal. Sometimes, often applying any treatments can create a change in the response variable. For example, when a child gets hurt, they feel better when their wound is kissed or covered with a Band-Aid, even though neither of those treatments actually take away the pain, okay? In our study, if only one group got a treatment, the fact that they were chosen to receive free soda might make their pulse increase before the caffeine even hits their bloodstream. That is known as the placebo effect. It occurs when a subject in an experiment knows they are receiving a treatment. This knowledge may cause a change in the response variable, which confounds the effect of the treatment. Okay, so there's your vocab word. In other words, we will not know which caused the change in the response variable, the explanatory variable or the placebo effect. Of course, it is essential that the subjects do not know which treatment they are receiving. When a person does not know who is receiving the treatment, the person is blind. Okay, so there's a vocab word. There are 2 classes of individuals who can influence the results of an experiment. Okay, those 2 classes of individuals are, let's see, we have to think about it. Those that are doing it, okay, so they're doers. And then the evaluators. So the subjects, the treatment administrators, those involved, they could influence, but also those who evaluate the results could influence, okay? When every individual in one of these classes is blinded by an experiment, the experiment is called double blind. Okay, and let me read it again because the bell rang. When every individual in one of these classes, so both the evaluators and the people doing it, don't know who had the placebo or who had the caffeine, it's called double blind. Okay? Oh, I read that wrong. If every individual in one of the classes, okay, just one of the classes, then it's blind. If it's both of the classes, then it is double blind, okay? Can our experiment be run in a double blind manner? The answer is yes, if nobody knows who got caffeine. So maybe we have 3 students that set this up, okay, and they split up the caffeine and the caffeine-free Coke, and then they put them all in the same cups and they give them to the people in the room and say, this is how you're going to administer it. Then those guys leave. They do nothing else with the experiment. So the people in the room administer it. They just have cup A and cup B, and then later when people look at the results, okay, they don't know what was in cup A and cup B. They just know that maybe in cup A, heart rates were faster than those that got cup B. And so they come back and say, whatever was in cup A, that affected the heart rates. Afterwards, they go find those 3 people that originally set it up and said, which one had caffeine? That would be double blind, okay? So don't we need someone to know? Yes, those would be the 3 people that came in. So you have to be very careful with that. The rest of this we will finish in class. Don't forget to read.